Thanks, Jerry. Good afternoon, everybody, and thanks for sticking with it. I know it's getting late in the day, and you guys are probably all drinking from the fire hose a little bit. Oh, look at that. Okay, so the S34-1 ad hoc group is focused on the video subsystem, and a lot of people think, well, that's really simple. It's just a video codec, but it's actually more than that. And we've heard earlier in the day about the broad range of capabilities of the physical layer and of the underlying transport layer. So we think about video now. We think there's actually not just one video size. There's not just one resolution. There's not just one frame rate. There's not just one color volume. And something happened to the slide in translation. The down and to the right should show sort of standard dynamic range and high dynamic range. So if you think about it, we have a number of degrees of freedom for video. So what was fairly straightforward in A53 and maybe even in A153 is a bit more complex now. And we know that the broadcasters are interested in a variety of business models, and the business models may evolve over time. So, so we want to have a lot of flexibility in each of these dimensions, and that presents some challenges that S34-1 has grappled with. Oh, there it is. So, after a considerable amount of time, S34-1 has made some consensus decisions, but still has a number of topics which are in progress and under evaluation. So fortunately, there's consensus on HEVC as the core video codec using the main 10 profile. The main 10 profile has been shown to compress 8 and 10-bit content efficiently. And actually outperforms the main profile on 8-bit content, which is a bit counterintuitive, but the additional tools available in main 10 actually give it an advantage. 420 color volume, 8 and 10-bit pixels. There's consensus to include both integer and fractional frame rates. This has been a hotly debated topic. The debate's gone on for quite some time. And we still don't have a decision beyond 60 frames per second. So for example, both 5994 or 60 over 1.001 for Pat and 60 integer will be supported. But when it comes to frame rates above 60 frames per second, there's still discussion. So there could be, let me call it 120 fractional or 120 integer. And of course, the European standards that are based on 50 may appreciate the inclusion of 100 frames per second as well. So what are we still talking about in 34.1? Well, we're talking about spatial scalability using what's called SHVC. SHVC is the scalable extension to HEVC. It's part of HEVC v2 standard, which was standardized some time ago now. We're still evaluating high dynamic range. High dynamic range is a very active topic, and I'll go into it in a bit of depth in a couple of slides down the road. Wide color gamut. Of course, A53 used Rec 709. That was sort of the standard color gamut. And now there's BT 2020, but there's also DCI P3, so you've probably heard these terms. And so there's a bit of discussion about exactly what will be supported and how we will organize our video subsets in ways that are well aligned with consumer devices. So I'll talk about that in a bit too. And then high frame rate. So, so for some time, we've been wrestling with the idea that there are these multiple degrees of freedom and that somehow we would need to aggregate parameters, put them in sets. The terminology that's sort of been agreed to after some time is called video characteristic sets. And we don't have consensus on this yet, but we're sort of converging on something that's going to look roughly like this. There would be, on the left, you'll see legacy HD and legacy SD, and those will include interlace, and those will only be Rec. 709. They won't use wide color gamuts, nor will they support high dynamic range. They will be roughly the equivalent of what's available today, substituting HEVC for MPEG-2 as a video codec. Then we will have additional video characteristic sets, which will be targeted at different classes of device. And the primary axis for those different classes of device will be the level of HEVC that is supported. So some devices will be less than HD. They'll perhaps support HEVC level 3.1. Then we'll have, and I'm going right to left, so forgive me for that. Then we would have a different characteristic set that would go up to 1080p, and that would require an HEVC 4.1 decode. Then we would have something that went up to 4K at 60 frames, which would require an HEVC 5.1 decode. And then we would have up to 4K with high frame rate that will require an HEVC 5.2 decoder. So different consumer electronics manufacturers will make different choices about how much computational power would be in those devices. And so the broadcasters could basically signal in aggregate where we have these collection of tools and of complexity, and that would be a video characteristic set, and that would be signaled with a single signal, as opposed to trying to have a number of independent signals. For all those video characteristic sets that are on the right-hand box, these would be progressive only. They would be 16:9 square pixels, and they would be capable of high dynamic range or wide color gamut, which could be signaled separately. So I see some people scratching their heads, so when it's questions time, I'm happy to come back to it. But we believe this sort of gives us a path to support legacy services and not make people change anything but the codec technology, and also to really move into the future and into 4K and into high frame rate, wide color gamut, and high dynamic range. Let's talk a little bit about HEVC. So probably a lot of you have heard HEVC. It's the latest of the MPEG standard video compression technologies. And people always ask, well, what kind of bit rates am I looking at? You hear anything from 30 to 50% better than AVC or H.264. You hear things like double or half the bit rate, twice the performance of MPEG-2. So this slide sort of makes some rough assumptions based on HD AVC being roughly 9 megabits per second, which is an operating point that some people have chosen, maybe not in broadcast, but in video distribution. So we're saying the rough equivalent for HEVC at HD would be, for the same video quality, would be about 5 megabits per second. For 4K, it would triple to about 15 megabits per second. There's a rule of thumb in video coding which basically says when you double in each dimension or have 4 times the pixels, you roughly have 3 times the bits to encode them. So, so when we say that 4K introduces a 300% overhead, that's where that comes from. So the slide shows then if you start adding on some other things like high dynamic range, high frame rate, wide color gamut, you have increments, but those increments are much less than the overhead of 4K. So some broadcasters have said, we really want the option to have maybe HD and HDR, or HD and HDR and high frame rate. So we think these are ballpark, and this would be 60 frame per second numbers, except for the high frame rate, which would go to 120. So I mentioned that one of the topics that's been discussed in S34-1 has been SHVC. So the idea here is really to leverage the flexibility of the physical layer in order to support the idea of either fixed and mobile services or more robust services that don't fall off a cliff as you get to the edge of a coverage area. With a two-layer video encoding, and the proposals have been specifically limited to two-layer. So for example, an HD base layer with a 4K enhancement layer. You could actually take those two layers and put them into two different physical layer pipes, or use the different LDM capabilities and have different levels of robustness for those two layers. So you could take that base layer and deliver it with high robustness using some of the stronger FEC codes and the modulation encoding of the physical layer, and you could take that 4K and you could actually have very light robustness and high efficiency. And that would allow different classes of receivers to be able to receive your video on different devices with different conditions. So what we currently have ongoing in S34-1 is what we call a common conditions experiment. The terminology is borrowed from MPEG. What we're trying to do is we're trying to compare the layered or scalable approach against simulcast. SHVC has the advantage of being more robust to losses than a single layer, but a simulcast might be a good basis for comparison. And what we're looking at is how much bitrate savings would we get with a scalable compression approach? Is it worth the complexity of introducing scalable video into ATSC3? We have leveraged Jim Kutzner's groups, the S32-4 groups, tools which define some different use case scenarios and define some different the physical layer pipes. We've backed out from those physical layer pipes the kind of bit rates that we're targeting for each of these use cases. So the use cases are mobile enabled, which you could think of as maybe being in a car or a train. That's sort of a at-speed experiment. Then we would have a pedestrian phone or tablet, so that might be a mobile pedestrian scenario and indoors in the Starbucks kind of environment. The third one might be interesting for a number of broadcasters, which is an increased coverage area. The test scenario is basically put 4K everywhere you have A53 today, and then have an HD service that extends beyond. And then the fourth one is tablet in bedroom, which is more a stationary indoor test, slightly different from the pedestrian test. We set this in motion. We have some content from broadcasters, particularly from Sinclair and from PBS, and we're really happy that we've been given some content to do these tests with. And results should be coming in the next, by the end of May or by early June at the latest. And we look forward to being able to really objectively evaluate SHVC as a technology for broadcast. This slide sort of repeats what we were saying earlier about the relative bandwidth demands of the different tools that we're looking at. And I would put this information up again to justify the strong interest in high dynamic range. So if you look at the different overheads, we've said that going from HD to 4K is a 300% overhead. If you look at HDR, HDR is, people say 20 to 25%. Color gamut is maybe 10 to 15%. 10-bit bit depth is a no-brainer. So again, the better pixels argument as opposed to the more pixels argument seems to be carrying a lot of favor with broadcasters right now. And so we want to just sort of move on and talk a little bit about high dynamic range and what it is and why it matters. So So for those who haven't seen high dynamic range, the technology's been around in still picture cameras for some time, and now it's finally become practical for video. Interesting as devices have come to market that are capable of going beyond the standard display. The standard dynamic range, or SDR, is calibrated to 100 nits peak luminance, as you probably know. With HDR, you can go far beyond that. Some people, there's a fair amount of discussion about whether the peak luminance should be 400 or 1,000 or 2,000 or 4,000 or 10,000 nits, but it'll be more than 100. Beyond being just brighter, HDR gives you details. And if you look, and it's pretty hard to see on the screen, but you can get a lot more details in the mid-tones of the picture, which we think, people will say there's better pixels there, that the video quality is noticeably better, not just because it's brighter, but because it's more detailed, and for a relatively low cost in compression, you get a significantly better picture. But HDR introduces a complication. The complication is, well, either we have content that's shot and produced in HDR, and now we have to make it available to both HDR displays and standard dynamic range displays, or we have content that's shot at standard dynamic range, and same problem. We have these two classes of devices, and maybe they're not even two. Maybe there are a wide variety of devices that have different peak luminance and different characteristics. And how do we adapt the content? How do we code the content? And do we need to send metadata? And how do we properly render that content on a wide variety of devices? So, the bottom middle box has a little curve, and we call that tone mapping. So just when we say tone mapping, we typically mean going from HDR to standard dynamic range, and we use the term inverse tone mapping to go the other way. My next slide, I have a picture of, we actually would say regrading if it's done sort of in the production side. If it's done at the consumer device, we would say it's inverse tone mapping. And so I hope it actually looks reasonable on the screen, but you can see we're not just talking about brighter, we're talking about much more detail and much more crispness. And when you look at HDR video, the difference is quite dramatic. So where are we in terms of high dynamic range? In S34-1, I think Madeline said yesterday in the TG3 meeting, we've sent more liaisons and received more liaisons on HDR than she could fit on a slide. The reason is that so many SDOs and industry forums are addressing the HDR topic, and ATSC wants to be aligned with them to the extent possible, and therefore BDA, Blu-ray Disc Association, BDA actually just confirmed a standard. I think there was some press yesterday that for the first time included Ultra HD, being the umbrella term that would include both 4K and HDR. SMPTE has standardized a way to convert HDR, which is typically in floating point, down into a 10-bit or 12-bit representation. Those are called EOTFs. There's some interest in aligning with the SMPTE standard for ATSC. SMPTE has also defined a standard for the carriage of metadata that could be associated with the conversion process to go back and forth between HDR and standard dynamic range. CEA and the HDMI forum have had to work on standards that would carry this to consumer devices, and so actually, to some extent, in response to the BDA's push to get HDR in, some new CEA and HDMI forum standards have come out. And of course, the ITU's been involved quite a bit, and I think the upcoming ITU meeting in the summer will have a lot of interest around high dynamic range. In addition to that, there are two sort of newly formed industry groups, alliances, that are addressing the UHD and HDR topics. One is called the UHD Alliance, and the other is the Ultra HD Forum. And so what you see are everyone's trying to come together and find common ground solutions, and ATSC doesn't want to be an outlier, but at the same time, ATSC's under some pressure on the time schedule that some of these groups aren't under. So hence the liaisons, hence the amount of effort to try to coalesce input from different groups in order to come to a conclusion on what is needed for high dynamic range that will keep ATSC in line with other standards and parts of the production and distribution ecosystem. So right now, we have one of ATSC3's famous small groups being led by Glenn Reitmeyer of NBC Universal and Clyde Smith of Fox to give us detailed technical requirements on HDR so that proponents can propose solutions. And this has taken quite a bit of time and has spun quite a bit as the industry has moved on HDR. So what are we considering? Well, we're considering what I mentioned before, this EOTF, the way to translate between the floating point native representation of high dynamic range video and the 10 or 12-bit integer representation that can actually go into a codec. Metadata, there's a notion of static and of dynamic metadata. Some people are allergic to metadata, so we consider their sensitivities. Single versus dual layer, there are some people who have, there are some companies that have espoused solutions. Some are single layer and some are dual layer. So an enhancement layer, kind of like our spatial enhancement layer, might be used to provide a high dynamic range extension such that you could have both a legacy picture and a high dynamic range picture rendered properly. With a single layer, it's more complicated. You need to map it somehow, perhaps using metadata. And 10-bit versus 12-bit. I think there's some debate about the necessity for 12-bit, and some of that is related to the peak luminances sought. So there's a number of dimensions within HDR that are still being wrestled with. We're hoping that Glenn and Clyde will lead the team to give the broadcasters view of what they want, at which point we'll ask for a call for contributions, an internal ATSC3 call for proposals, and we'll get some solution proposals on the table. I mentioned wide color gamut, so just for those who are not so familiar with wide color gamut, Rec 709, which is the inner triangle, is sort of the range of colors that is visible or able to be rendered with current technology today. And you can see you don't get quite the great color rendering when you have a display that doesn't do beyond 709. But you can see that there are deeper reds and pinks that aren't able to be rendered today, or certain greens or certain blues, right? That these triangles grow as you extend beyond 709. So there are a number of people who feel like 709 is insufficient. The obvious next step in terms of a standard is the Rec 2020, and then in the middle there's something called DCI P3, and that is a standard that is digital cinema, DCI's digital cinema group, and one of the things that's been proposed is to take Rec 2020 as the container, but only use the values within the DCI P3 box. So, so we're still coming out to what is practical, what is needed, and what can televisions actually do. There are no devices today that can do the full Rec 2020 color gamut, and I'd be remiss if I didn't point out that Hollywood guys have another color gamut called the XYZ, which is all that is all visible light, which we think is probably a little out of scope for ATSC. Okay, so where are we? So we've kicked around the video input formats, and we now have video characteristic sets, and they may move a little bit from what I showed, but there will be a number of different video characteristic sets defined, and we'll be able to close the book on the video input formats. The core video codec is HEVC with perhaps the SHVC scalable extension. High dynamic range and wide color gamut, you can see, will probably extend out into October, and we think that the candidate standard draft for video may not have HDR and wide color gamut included, and we may actually have to add that in later. And we're told that that's okay because candidate standards are malleable. I should also mention, I didn't mention in this presentation 3D. We did have a call for contributions on 3D. We think it's important. There were a number of 3D requirements, and we have one proposal which will be evaluated and adopted in some form, and we expect that to be done in time in the end of July. So we think that by mid-July, we should have something that looks like a candidate standard with the exclusion of HDR and wide color gamut, and hopefully during that period, we will be able to receive some proposals, some contributions, and have an evaluation. And current plan is to have that evaluation done and HDR technology specified by the end of October. Okay, so thanks very much. And any questions? Pat.
Alan, you're the clearest of the ad hoc chairs to delineate this issue, but you're about the fifth out of today. And so Rich and Mark and Jerry, I think we are beginning to realize we've got a bunch of cross-silo requirements, HDR and wide color gamut signaling being the latest, which means that we're going to almost certainly have to turn the crank at least twice on each of the candidate standards once they're published. Because somebody down in S33 has got to figure out how to do the signaling and what the signaling is and so forth. So this process isn't going to be as simple as folks would like it to be. It's messy already, it's going to get messier. So.
I don't disagree with you. I will say we intend to be very clear about the signaling requirements for video as soon as the video characteristic sets are nailed down.
Yes, but you can only go so far until you get into the transport area, and then it's theirs.
Thanks, Pat. Any other questions? Thanks very much.